Hello friends, myself R.D. Mahajan presenting my video on Leibnitz Theorem. Let us prove the problem. If y is equal to sine inverse of x, then prove that first one, 1 minus x square into y2 minus x into y1 is equals to 0. And the second result, 1 minus x square into n plus second order derivative of y, yn plus 2 minus in bracket 2n plus 1 into x yn plus 1 minus n square yn. And if we observe the terms of y are yn plus 2, then yn plus 1 and yn. All these derivatives are in decreasing order. And whenever we have such type of terms, it becomes a problem of Leibniz theorem. Nowhere it is mentioned that it is a problem of Leibniz theorem. By observation, we have to decide whether it is Leibniz problem or not. And as it is Leibniz problem, we try to apply its technique. Therefore, here given function is y is equal to sine inverse of x, which is function of x. Differentiating it with respect to x to get the first result, and we have to differentiate it twice. Therefore, first time differentiating with respect to x, we get first derivative as y1. Derivative of sine inverse x is 1 upon root of 1 minus x square. Then cross multiplying it, we get root of 1 minus x square into y1 is equals to 1. Then squaring it, to cancel that square root sign. Therefore, the square of this is 1 minus x square into y1 square is equals to 1. Square of 1 is 1. And then differentiating again with respect to x. Differentiating again with respect to x. Here it is a product. Therefore, applying a product rule, UV rule. First function 1 minus x square. Differentiation of y1 square is 2y1, and as it is function of function, applying chain rule. Next derivative of y1 is y2 plus second term as it is y1 square, and differentiation of 1 minus x square is minus 2x, and that equals to differentiation of 1 is 0, and therefore we get 1 minus x square and that y2. The excess term is 2y1. Therefore, cancelling that term by dividing 2y1, we get 1 minus x square into y2. 2y1 get cancelled. Dividing here by 2y1, we get minus x into y1, and that is equals to 0. Result number 1. The first result, 1 minus x square into y2 minus xy1 and equals to 0, we get the first result. Then, to obtain the second result, we have to obtain the term yn plus 2 with the help of y2, and it is possible if we differentiate it n times, and therefore it is the nth derivative of the product of these two terms, means we have to apply Leibniz theorem. Applying Leibniz theorem, which states like this: nth derivative of the product uv as unv, next n into un minus 1 into v1 plus n minus 1 by 2 factorial into un minus 2 into v2, and so on. The last term is u into vn. All the suffix stand for the derivatives. Here the derivatives of u are in decreasing order and derivatives of v are in increasing order. And as already I have stated that important point, we have to consider the function v such that we get finite derivatives for that term, and therefore nth derivative of the first term, here it is 1 minus x square into y2. We consider the first term 1 minus x square as v, and therefore it is, and the second term as u, and therefore nth derivative of y2 is yn plus 2. We have to add suffix n with that suffix 2. Therefore, yn plus 2 is the nth derivative into v. V is here 1 minus x square. Next, un minus 1. Decrease the suffix by 1. We get next term as n. Decreasing it by 1, we get yn plus 1 as the next derivative. Into v1. First differentiation of this term with respect to x. It is minus 2x. Next one is n minus 1 by 2 factorial. Again decreasing it by 1. Therefore, next term is yn, decreasing that suffix by 1, into v2 means next derivative of minus 2x. It is minus 2. And next becomes 0 as the derivative of minus 2 is 0. We stop here. This is the nth derivative of the first term. Then differentiating the second term also with respect to x n times, applying Leibnitz theorem, we consider x as v and the remaining as u. Therefore, nth derivative of y1 we get as yn plus 1, adding n with that suffix 1, into v it is x. Next, n into un minus 1, decrease suffix by 1, we get next as yn. Derivative of x, differentiation of x with respect to x is 1. Next derivative becomes 0, we stop here, and that is equals to 0. This is the application of that Leibniz theorem or use of Leibniz theorem. And then we have to combine the terms, similar terms in one bracket. Only one term of yn plus 2. I will keep that as it is, 1 minus x square into yn plus 2. Then 1 and 2 terms of yn plus 1 minus x into yn plus 1 I can take common. Here remains 2 into n, and when we take this much as common we get plus 1. Next, this 2 to get cancelled. We can take yn common from this 2. Here it is n minus 1 and plus 1 when we take yn as common term, and that is equals to 0. And then simplifying it, we get 1 minus x square into y2, no change. This one is minus 2n plus 1 into x multiplied by yn plus 1, and minus 1 plus 1 get cancelled, n into n we get n square yn at 0, result number 2. Or required result number 2. Therefore, by applying Leibniz theorem we get the second result, or required result number 2. One more problem on Leibniz theorem I will discuss in my next video. If you like my video, please share it, as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you for watching.